A person with upper arm vertical and forearm horizontal holds a mass of 4 kilograms. The mass of the forearm is 1.5 kilograms. Consider 4 forces acting on the forearm. F by the bones and ligaments of the upper arm at the elbow. So the force F over here. T by the bicep. So it's the force on the bicep, the muscle. 40 Newton by the mass that you are holding in your hand, that is 4 kilograms times approximately 10 meters per second squared of the gravities, give you the 40 newtons. And 15 newtons as the weight of the arm, because they said that the weight of the forearm was 1.5 kilograms. So this 1.5 kilograms times approximately 10 newtons per meters, Newton meters per second squared of acceleration of gravity. It gives you the 15 newtons you see over here. So they say the points of applications are given in the drawing. Calculate the vertical components of the force F. So the force on the elbow, the force on the bones, and T, there is the tension on the bicep. So we're going to use the conditions of static equilibrium. So for translational equilibrium and rotational equilibrium. So the first that I'm going to do is to apply the condition of rotational equilibrium. Let's say that the sum of the torque with respect to a given point is equal to 0. And I will make the torque with respect to this point over here. There is just the point where the force of the bonds is acting. So I will call this point 8. In my diagram, this point 8 is this point over here. So we will make the sum of the torque with respect to that point. We made the torque with respect to that point because doing that, I will have only one unknown in my equation of torque. That would be the tension on the bicep. So I say the sum of the torque with respect to point 8 is going to be 0. I will be taking positive the torque that are counterclockwise. Now, to find the torque with respect to point 8, I will analyze, what is the arm of each force, right? I will use meters. Really, it doesn't matter in this case, but I would prefer always to use meters because are the units of the international system. And then I have that the force T, the tension on the bicep, makes a torque counterclockwise here. And the arm of this force is 5 centimeters, which is 0.05 meters. So we say that the torque that is positive is the torque due to T and is 0.05 meters, which is 5 centimeters times T. Now the torque due to the force of 15 newtons is negative because it's clockwise with respect to A. The distance from the force of 15 newtons to A is 15 centimeters. So we will say minus 15 centimeters, which is 0.15 meters, times the force of 15 newtons. And then now the force of 40 newton also makes a clockwise torque. So we say minus. Now I am adding the distances, right? So I have 23 plus 15, which is 38 centimeters. So it's 0.38 meters times the force of 40 newtons. And all this is equal to 0. So solving for T now, we get that T is equals to 0.15 meters times 15 newtons plus 0.38 meters times 40 newtons divided by 0.05 meters. So when we calculate the tension, we get that the tension here would be 349 newtons, right? Which is going to be approximately 350 newtons. Like that, we express this with two significant figures. Now, as I know the tension, now I'm ready to calculate the force F. And to calculate the force F, I can make a sum of the forces in Y using the condition of translational equilibrium. So we say that the sum of the forces in Y is equal to 0, and I will be taking positive the forces pointing up, right? So we say that my forces in Y are in this case the tension that is pointing upward, so it's positive. And then I have the force F, and I have the force of 15 newtons that is also negative. And I have the force of 40 newtons that is also negative. Now this is equal to 0. Solving for my force F, I will get that minus F is going to be 50 newtons plus 40 newtons minus the tension. So F would be multiplying by minus 1, the tension minus 50 newtons minus 40 newtons. If the tension is 350 newtons minus 15 newtons minus 40 newtons, we get that the force in F, the force acting on the bond, would be 295 newtons in this case. So this is the magnitude of the force on the bond. So here we found the force acting on the bicep, and we found the force acting on the bond of the person.